Hello students, welcome to Unit 6 Notes, Section 8.2. In this one we're going to find the missing, in this one we'll find the missing side lengths, leave our answers in simplest radical form. Well, when we take a look at a first triangle, you say, well, wait a minute, we know how to find it, one of these missing sides if we are given two lengths, any two lengths, whether that be in a right triangle, whether that be a leg and a hypotenuse or two legs. But how do I find it, both of these values? Well, let's take a look. What's special about this triangle is it has 180 degrees, but we take away 90, we get 90. We also take away 45. That leaves us with 45. So this angle right here has to be 100. It has to add up to 180. It has to be 45 degrees. Therefore, we know that this is congruent to this piece, meaning that y has to be 6. So no matter what, in this case, y is going to be 6. And now what I can do is I can do some algebra to find x, which I'm going to do right now. So we're going to say leg squared plus leg squared equals hypotenuse squared. So 6 squared plus 6 squared equals h squared. Oh, and you know what? H, that's actually 8. I'm sorry, it's x. So 36 plus 36 equals x squared. 72 equals x squared. Now I'm going to find the square root of both sides. So x is equal to the square root of 72. Let's take a look. Square root of 72 is irrational. So what are some numbers that go into 72? Well, let's see. 4. 4, the perfect square of 4 works. But notice 18 has a 9 and a 2, so we can go a little bit further. So let's go 9. All right, 8 has a 4 and a 2, obviously. All right, so 16 doesn't work. If that's 4 times 4, 5 times 5 is 25. That doesn't work. 6 times 6 is 36. Okay, so it's 36 and 2. That works out well. So x is equal to the square root of 36 times the square root of 2. So x equals 6. 6 square roots of 2. Not too bad. 6 square roots of 2. All right. Well, take a look here. Look at 36. Isn't the square root of 36 6? And there were 2 of them. That makes sense. Why 36 ended up being a pretty decent factor to use here, greatest factor. So here we are again. We have, let's see, 45 degrees here. All right. 45 degrees, making these congruent. So we'll have, this is equal to 3. So y is equal to 3. Now we're going to solve for x. So leg squared plus leg squared. Maybe I should change the colors on this. That was, yeah, let's change it to blue using different colors than the last one. Okay, so now leg squared plus leg squared equals hypotenuse squared. So 3 squared plus 3 squared equals x squared. So 9 plus 9 equals x squared. 18 equals x squared. So x equals the square root of 18. Well, 18 we should know is not a perfect square, and 18 is divisible by 9. So it's 9 and 2. So x equals the square root of 9, square roots of 2. X equals 3 square roots of 2. Well, take a look again. There were 2 9s. The square root of 9 is 3. There were 2 of them. All right, so 3 square roots of 2. And there we are. Now, if you look at this, we had a ratio. We have a ratio going on here. Look at this. 6, 6, 6 square roots of 2. 3, 3, 3 square roots of 2. There's a pattern, and that's the pattern we're going to look at today. You should notice that the side length times the square root of 2 is what the hypotenuse will always be. If, you know, given a right triangle that has that's an isosceles triangle that has a 45-degree angle and a 45-degree angle, this is going to happen. You're going to learn this ratio and one other ratio today. So this is called a 45-45-90 triangle. The only other one is a 30-60-90 triangle, and they all have special ratios. So in this case, we have the leg times the square root of 2 will give us the hypotenuse, right? 3 times the square root of 2 is 3 square roots of 2. That will always give us our hypotenuse. So let's go on to, here's the first theorem using 45-45-90 triangles. And we have, in a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of the leg. So what I'm going to do is I'm going to, let's call this, let's summarize this. So this right here, I can say h is equal to the leg times the square root of 2. L in this case, L is the short leg or the long leg. It doesn't matter. We could write it this way, or we could say h is equal to s times the square root of 2. It doesn't matter. These are equivalent leg lengths, so it doesn't matter what they are. It is, you're going to multiply the leg times the square root of 2, and you'll get your hypotenuse. So let's just say, let's use this one. Let's use this one. L meaning leg, but S meaning short leg, okay, because they're both the same thing. So H equals S times the square root of 2. For 30, 60, 90, we have two equations. We have a ratio where opposite the 30, opposite this 30, has a length. Opposite the 60 is that length times the square root of 3. And opposite the 90 is double the length of S. So whenever I take this length, I don't know what it is, but if I move it here, it will take 2 of them to fill it'll take 2 of them to fill the length of the hypotenuse. So that's your ratio, okay? Short leg, long leg, hypotenuse. So let's call this one H equals short times 2, and L equals short times the square root of 3. What this will do is this is a ratio that we'll work with. So our long leg is equal to the short leg times the square root of 3, and the hypotenuse is equal to the short leg times 2. Now notice the square root of 3 is not greater than 2. The square root of 3, let me delete some of these. Okay, the square root of 3 is about 1.7. So that's its ratio. It's about 1.7 times greater. So the long leg is about 1.7 times greater than the short leg, where if we double it times 2, we get the hypotenuse. So these are our two equations. So you know what? It doesn't really matter which one we use for this one. I guess we could call it long leg. h equals long leg times the square root of 2 for this one. This one, the order is going to matter because there is a short leg and a long leg and a hypotenuse. Okay, this is a proof for it. But yeah, so in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root of 3 times the length of the shorter leg. And pretty much what we're going to do is if you're given the short leg, you're in a really good situation. You're going to put the short leg in for both of these. You'll quickly find the length of the long leg. You'll quickly find the length of the hypotenuse. Done. Very easy. And if you're given the hypotenuse, not too bad. You put that number in here. You divide both sides by 2. You'll get the short leg. Then you can put the short leg in here, and boom, you have the long leg. That's pretty easy as well. The most complicated one is when you're given the long leg. And the reason why opposite the 60 degrees is your long leg. We'll call this one the short, the long, and the hypotenuse. And the reason why it's difficult is because you have to divide by the square root of 3. Well, you're going to have something that's irrational. And because it's irrational, then you're going to have to do more work to solve for the short leg to get it to be rational, and then you're going to put the short leg in here and you're going to double it. Not too bad, but the long leg will be the most difficult one. So the acute angles of an isosceles triangle are both 45. Here's the proof of it. Yeah. Okay. Let's find the length of the hypotenuse in a 45, 45, 90. So instead of doing leg squared plus leg squared equals hypotenuse squared, you're just going to write h equals s times the square root of 2, leg times the square root of 2. So here, 9, these are my L's. So you can pick either one. And that's your h. So I'm going to put h equals 9 times the square root of 2, and I'm done. It is 9 square roots of 2. Whoops. Again, let's go back to the original here. 6 square roots of 2. 3 square roots of 2. In this case, 9 square roots of 2. You're just going to multiply that by the square root of 2. Either one of the legs. So here you have a leg that is going to be 2 square roots of 2. Right? This is your leg. That's your other leg. Here's your hypotenuse. So we have h equals leg times the square root of 2. Times, square root of 2. Long leg or short leg doesn't matter, that both legs are the same size. So call it S or L, doesn't matter for this equation for 45, 45, 90. Now we know L, we're going to do h equals, the leg is 2 square roots of 2. Yeah, I can pick either one of these. They're both 2 square roots of 2. So it's 2 square roots of 2 times the square root of 2, right? Because that is your L. Just substituted L in. So h is going to be equal to 2 square root of 2 square root of 2, which is square root of 4, right? Don't forget multiply the things inside. Will stay inside. So h equals 2 times 2, so h equals 4. So in this case, x equals 4. Because we're solving for the variable x. All right, so in this case, the hypotenuse was actually 4. This was 4, and each one of these sides was 2 square roots of 2. So 2 square root of 2 times the square root of 2 gives me 2 square roots of 4. The square root of 4 is 2, so it's 2 times 2, which is 4. Okay, it's a little bit more difficult when it involves radicals. What I could do is I could work backwards from the hypotenuse, which is 4, to find that these are both 2 square roots of 2. Okay, and if you wanted to work backwards, what you would do, working backwards, I'll put some work right here, working backwards. This is the tough part. So h equals L times the square root of 2. You were given 4 equals L times the square root of 2. So let's divide both sides by the square root of 2, and that gets you this, right? So L equals 4 over the square root of 2. But the issue here is that it's irrational. Notice this answer, this side length, 2 square roots of 2, looks different than 4 over the square root of 2. Let's check if it is. 2 square roots of 2 is that. 4 divided by the square root of 2 is that. Notice they're equivalent. They look different. They look way, way different. 2 square roots of 2 is 2.828, and then 4 over the square root of 2 is 2.828. It's the same thing. So how do we get it to look different? What we have to do is this thing called rationalizing, which we did before. We don't like the way that looks. So what we're going to do is we're going to multiply this by something that will fix the square root of 2. I can't find the square root of 2, but I can find the square root of 4. I can find the square root of 16. I can find the square root of 100. So I need to do something here to make that 2 either a 4, a 16, 100. I think a 4 might be easiest, so I'm going to multiply it by the square root of 2. That'll give me the square root of 4. But whatever I do in the denominator, I also have to do in the numerator, because the square root of 2 over the square root of 2 is really just the number 1. So multiplying it by the number 1, it's called rationalizing, and I'm just doing that to make it, I'm making it look different without changing its value. 5 times 1 is 5, even if I call it 2 over 2, right? If I multiply it by 2 over 2 and I get 10 over 2, that's still 5. It looks different, but I didn't do anything to its value. So in this case, we'll get 4 square root of 2 over the square root of 4. The square root of 4 is 2, so it's going to be 4 square roots of 2 over 2. And what's 4 divided by 2? I can stay on the outside here. I get 2 square roots of 2, which is my leg. And that was working backwards. That's working backwards to show you that if the hypotenuse was 4, it really has a length of a leg that's 2 square roots of 2. All right, here we're going to have to rationalize because they think we're involving a radical. Oh no, the leg has a length of that. Okay, so here we have a leg. This is a leg. So it's a 45, 45, 90. So h is equal to the leg times the square root of 2. They're both a short and long leg, so it doesn't matter. So we're going to say h is equal to 5 square root of 3 times the square root of 2. So h equals 5 square root of 3 square root of 2. H equals 5 square roots of 6. And that's it. We're done with this one. There's no simplifying of the square root of 6 I can do, so we are done with that. All right, so here's a 45, 45, 90 again, finding the length of a leg. So in this case, we have h equals L times the square root of 2. Again, short or long doesn't matter. Here's our L's. Here's our H. Our H is 6, so I'm going to evaluate 6 in here. And I'll divide both sides by the square root of 2. So we get leg is equal to 6 over the square root of 2. The problem is that it's not rationalized. And so again, we're going to have to rationalize it. So we'll multiply it by the number 1, which I'm going to make look like this, which will give me 6 square roots of 2 over the square root of 4. And then that gives me 6 square roots of 2 over 2. And 6 over 2, which is the only thing I can do, 6 over 2 is 3 square roots of 2. So the legs here are both equal to 3 square roots of 2. In this case, whoops, and so it's the value of x. So x equals 3 square roots of 2. I just need to replace my variable. It wasn't asking for L, it was asking for x. All right, again, quickly, put in 6, divide both sides by the square root of 2, which gives you a 6 over the square root of 2. Rationalize. Multiply by 1 to make it look different. A number equivalent. I'm just going to leave it at rationalize because it's rationalizing. You can rationalize numerators or denominators. So let me just leave it like that. Okay. Here, this one has a hypotenuse of 10. So I'm going to say this is, where am I at? This is a hypotenuse, what, 10? Nope, hypotenuse of 10. Okay, so I'm going to do h equals L times the square root of 2. So 10 equals L times the square root of 2 divided by the square root of 2. So L equals 10 over the square root of 2. Then I'm going to rationalize. So I'm going to multiply by the square root of 2 over the square root of 2. Remember, it's not just the square root of 2 over the square root of 2. It could be the square root of 3 over the square root of 3. It can be whatever. I just know the square root of 2 over the square root of 2 is going to get me where I need to go. So it's 10 square roots of 2 over the square root of 4, which is 10 square roots of 2 over 2, which ends up being 5 square roots of 2 when we do 10 divided by 2. Okay, so the leg, in this case it wants a leg, so leg is equal to 5 square root of 2. It makes sense too. 5 square roots of 2 is lesser than 10, right? 5 square root of 2 is 7.07. All right. Here we have example 3. A high school softball diamond is a square. The distance from the base to the base is 60. How far does a catcher throw the ball from home plate to second base? So we're going from home. Let's do, here's home. 1, 2, 3. This is 60 feet, which makes this 60 feet, which, as we know, if h is equal to leg times the square root of 2, h is equal to 60 times the square root of 2, but it wants it to the nearest foot. So we're going to say the diagonal is equal to 60 square roots of 2, but we're going to say the diagonal is approximately equal to whoops, I'm on the wrong. It's about 84.852, 853, 84.85, 84.85. And so it says high school softball diamond, to the nearest foot. So we're going to say, how far does the catcher throw the ball? We'll say the catcher throws the ball approximately 85 feet from home plate to second base. Let's see one thing. APPROXIMATEOY. Okay, that looks very strange, but approximately spelled correct. Okay, that's that one. A square garden has sides 100 feet long. You want to build a brick path along the diagonal of the square. How long should the path be? So this is the same thing. We are going to say h is equal to L times the square root of 2. So the garden has sides, yep. So this is a side, so 100 square roots of 2. So the diagonal should be approximately about 141.42. 141.42. Okay, how long will the path be? Round your answer to the nearest foot. So we're going to say the path will be approximately approximately 141 feet long. And there we go. Again, it doesn't make sense to give this in the simplest radical form because it will it doesn't make sense to do so because we're talking about a real world example. You're not going to say 100 square roots of 2 feet long. Let's see. That's not what I want fully, but I'm going to say that was in feet. This one is also in feet. So we'll say 100 feet, 100 feet. And then this diagonal here is going to be approximately 141 feet, which is 10 square roots of 2. We'll leave that off. Okay, where this one was approximately 85 feet. Okay. Now we're moving on to the 30, 60, 90s. Let's start with this second one because this one is a little bit easier. And then we'll lead into the first one, which I think is more difficult. Why? They give me in the first one what's opposite my 60, which is my long leg. Here, they give me my hypotenuse, which I just think the short leg and the hypotenuse are the easiest to work with. So we're going to say, let's say h is equal to the short leg times 2. The long leg is equal to the short leg times the square root of 3. Those are my two equations. You need to write them out every time you do it. You are given the hypotenuse. So let's do hypotenuse, short, and long side. So given the hypotenuse is 8, so we're going to put in 8. So 8 equals short times 2. So short is equal to 4. So the short leg is equal to 4. And we'll do the variable later on. But now I'm going to put the short leg in there, and so we'll get long equals so long equals 4 times the square root of 3. So long is equal to 4 square root of 3. And now we just need to do the correct variable. So it looks like x is my short side. So x equals, oh, I'll do a totally different color just so it stands out. We really have to answer based on our variables. This is where you can make a mistake. You might write the wrong variable for the side length. So be very, very careful. X is my short leg, which is 4, and y is my long leg, which is 4 square roots of 3. So we have 4. Remember, it's double and then times the square root of 3. Let's see if our numbers make sense. 4 square roots of 3, 8. So 4 times the square root of 3 is 4 square roots of 3. 4 times 2 is 8. So these all make sense. All right, this first one is a little bit more difficult because you're given what's opposite the 60. So we are, let's see, okay, we are going to do h equals s times 2 and L equals s times the square root of 3. We got to find out which one we're given. And it appears we are given, let's see, here's my short. My short is opposite the 30. We're given D. Here's the hypotenuse, and we're given the long leg, which is 5. So we're given 5, so we're going to do L equals 5 times the square root of 3 divided by the square root of 3. Oh, I'm sorry. I put it in the wrong spot. Don't do that. Okay. We're given 5 is the long leg. Whoops. Sorry about that. 5 is the long leg. So now we need to solve for S. So we're going to divide both sides by the square root of 3. So we get S equals 5 over the square root of 3. But this is not good enough. We need to rationalize. So we're going to say rationalize. Okay, so we're going to multiply it by the square root of 3 over the square root of 3, which is going to give me 5 square root of 3 over the square root of 9. Again, I could have made 3 anything. I could have made it 36. I could have made it, what other perfect square? 9, 36, probably 144, but why not just make it 9? That makes the most sense. So I'm going to have, this is going to simplify to be 5 square root of 3 over 3. Boom. So my short side is 5 square root of 3 over 3. What I now need to do is I now need to evaluate it over here, and I'm going to do h equals 5 square root of 3 over 3 times 2. So just double 5, and you get 10. You don't multiply numerator and denominator. that would be the same thing as leaving it exactly the same. If you multiply both by 2, you get 10 square roots of 3 over 6. That's not the intention. You would then simplify it back down to 5 square roots of 3 over 3. Only multiply the numerator. So now you have your numerator and you have your, you doubled it. You have s equals, you have your short leg is equal to 5 square root of 3 over 3. You have your hypotenuse is equal to that. Let's look at the variables though. The variables, we are going to say, d is equal to 5 square root of 3 over 3, and f is equal to 10 square roots of 3 over 3. And that is because, 10 square roots of 3 over 3. So you have 5 square roots of 3 over 3, doubled it is 10 square roots of 3 over 3, but 5 square roots of 3 over 3 times the square root of 3 gets you 5, right? Think about that. 3 times 3 is 9, square root of 9 is 3, 3 divided by 3 is 1, so you're left just with the 5. So that does prove that that would work for that. All right, so let's skip this problem because this video is already getting quite long. It's not going to change anything because we still have a few 30, 60, 90s to do. So let's go on to 23, error analysis. So Sandra drew the triangle at the right. Rika said that the lengths couldn't be correct. With which students do you agree, and explain your answer? Well, when I first take a look at it, I notice that there's a length of 5, a length of 5 square roots of 3, and a length of 10. So I asked myself, well, does 5 square roots of 3, and 10 work? On the surface, they look like they do, right? Because if the hypotenuse is double the short leg, then 5 times 2 is 10. And if the long leg is 5, if it's the short leg times the square root of 3, we get 5 square roots of 3, which works as well. The problem is the location that these are in. Notice that this is the 30-degree angle, so opposite the 30 is your short leg, which doesn't have the 5. And 60 is across from the longer leg, which should be 5 square roots of 3. So the answer here is that these need to be switched. So we're going to say the values are correct. The values are correct. But are in the wrong, are in incorrect positions. So we agree with Rika. Who said that there was a problem with the way it was set up. All right. So find the value of each variable. Find your answers in this. Leave your answers in simplest radical form. So when you're doing these, what you're going to want to do is break up the. You're going to want to break this up. So if we break it up in this way, we see that we have a 30, 60, 90, right? And now we have a 30, 60, 90. It also looks like a square or a rectangle over here. Notice that this whole side is 6, but we'll be able to take this piece away to find this over here. So we're working a little bit backwards. To find B, we'll take whatever this whole length is, 6, and we'll take this piece away. And to find this piece, we'll need to know this piece, and we'll need to know this piece, which is right here. We're going to be doing our 30, 60, 90. So we have, let's see, 2 square roots of 3. If this is 2 square roots of 3, this is also 2 square roots of 3. So let's set up our equation. We're going to say H equals S times 2 and L equals, we're going to say L equals short times the square root of 3. And it looks like we're given our long leg because it's opposite the 60 here. So we're given the long leg. So we're given 2 square roots of 3 equals S times the square root of 3. Ooh, thank you for that. They gave us a decent one to work with. So we're going to divide by the square root of 3. And we get S is simply 2. And now we'll evaluate it in here, and we'll get H equals 2 times 2, so H equals 4. So 4, A is 4, because that's opposite the right angle. That's my hypotenuse. Opposite the 30 is 2. Now, hold on, this whole thing is 6. So what we have to do is we have to break 6 down and write it in 2 and 4. 2 parts of the 6 are here. Oops. 2 parts of the 6 are here. The other 4 parts are right here. And now we're going to travel across, and we'll say B is 4 because of that. All right, so A is 4 and B is 4. Not too bad. The next one, we're going to draw this right here. We'll have a 45, 45, 90. And what we're going to do, this is 4 right here. So whatever we get, this whole thing is B. So this is B is going to be 4 and whatever this is. That will be B. All right, so what we need to do is we need to set this up as H equals L square root of 2. It's a 45, 45, 90, so there's only one equation. We are given the H, we are given the hypotenuse. So we'll do 3 square roots of 2 equals L times the square root of 2. Thank you very much. They did it again. They made it pretty easy. We get L is equal to 3. So here, this part is 3. That part is 3, making this 3, because 3, this is going to go from here to here. 3 and 4, don't forget this 4 here, combined with the 3, B is a total of 7. So A equals 3 and B equals 7. All right. Same thing for this one over here. We're going to do, we have a 45, 45, 90. And this is going to be 6 because it's traveling from the left-hand side to the right-hand side. So H equals L times the square root of 2. They give me the L. So H is equal to 6 square roots of 2. So in this case, this is 6 square roots of 2. This is 6. So we have a 6 and a 6 here. This is 8, 8 and 6. This has to be 8. 6 and 8 is 14. So A equals 14. So A equals 14 and B equals 6 square roots of 2. All right. And then we'll be at our notes. So our notes will take us quite a while to do in class, but we'll get through them. I'm thinking I'll just have this ready to go for you. This will already be done, and you can just follow along with it. Okay. All right. Good luck on your IXL.